Hello and welcome. In this episode, we're exploring the sine rule, a useful method which can be applied to any sort of triangle, not just right-angled ones. The key to unlocking this powerful method is grasping the concept of side angle pairs. Let's begin by explaining this idea. Every triangle has 3 angles and 3 sides. For example, this triangle has angles of 47, 68 and 65 degrees. It has side lengths of 9.6, 8 and 10. Each of the angles can be paired off with the side across from it. If we look across from the 47 degree angle, we hit the side of length 8. So the first side angle pair is 8, 47. Looking across from the 65 degree angle, we reach the side of length 9.6. So the second side angle pair is 9.6, 65. Finally, going across from the 68 degree angle hits the side length of 10. So the third side angle pair is 10, 68. Along with an understanding of side angle pairs, it's also crucial to get comfortable with the following naming convention. Angles are labelled with capital letters and the opposing sides are labelled with the lowercase versions of the same letter. Let's illustrate this. Angles should be labelled with capital letters, so in this first triangle, I'll label the angles with capital A, capital B, and capital C. The side across from capital A should be labelled with lowercase a. The side across from capital B should be labelled lowercase b, and the side across from capital C should be labelled lowercase c. In the second triangle, I'll label the angles with the capital letters P, Q and T. The sides across from these angles should be labelled with lowercase p, Q and T. Before we introduce the statement of the sine rule, let's take some time to test your knowledge of side angle pairs. The sine rule states that, given 2 side angle pairs, A capital A and B capital B, we have the following. A over sine of capital A equals B over sine of capital B. The sine rule involves 4 quantities, 2 sides and 2 angles. If we know 3 out of the 4 quantities, then the sine rule will give us an equation which can be used to solve for the last quantity. Let's get some practice. In this triangle, we have one complete side angle pair, the 74-degree angle and the side of length 24. Let's label these with capital A and lowercase a. There's also another side angle pair labelled, the angle of 30 degrees and the side of x. Remember, the angles should always be labelled with capital letters and the sides with lowercase letters, so here let's label the angle with capital B and the side with lowercase b. The sine rule says that a over sine of capital A equals b over sine of capital B, so putting our values into the statement tells us that 24 over sine of 74 equals x over sine of 30. From here, algebra could be used to solve the equation and find the value of x. However, before we turn our attention to the algebra, let's get some more practice using the sine rule on some other triangles. In this triangle, the 28-degree angle and the side of 31 form a side angle pair. Let's label these capital A and A. The 125-degree angle and x also form a side angle pair. Let's label these capital B and B. Putting these values into the statement of the sine rule tells us that 31 over sine of 28 equals x over sine of 125. In our final example, the 36-degree angle and the side of 5.4 form a side angle pair. The angle of x and side of 9.2 also form a side angle pair. These can be labelled with capital A, A, and capital B, B. If we plug these values into the sine rule, we get the equation 5.4 over sine of 36 equals 9.2 over sine of x. We are now ready to see the sine rule in action from start to finish. The first step, which we've already practiced, is to correctly label the diagram and create an equation. The second step will be to use algebra to solve the resulting equation. In our first example, we have a triangle which contains angles of 42 degrees and 71 degrees. One side is labelled 14.7 and another side is labelled x. These four values form two side angle pairs. The 71 degrees pairs with the 14.7 and the 42 degrees pairs with the x. We should label these pairs capital A, capital B, B. The sine rule states that A over sine of capital A equals B over sine of capital B. Writing in our values tells us that 14.7 over sine of 71 equals x over sine of 42. To isolate the x, we'll need to get rid of the division of sine 42 on the right-hand side. We can do this by multiplying both sides by sine of 42. Typing the entirety of the left-hand side into our calculator and rounding to one decimal place, we get an answer that x equals 10.4. In our second example, we have a triangle with side lengths of 7.3 and 12.1. One of the angles is 82 degrees, and another of the angles is labelled x. Again, these four quantities form two side angle pairs. This is precisely the scenario where the sine rule can be applied. The first pair is an angle of 82 degrees and a side of length 12.1. We label these capital A and A. The second pair is an angle of x and a side of 7.3. We label these with capital B and B. Putting these values into the statement of the sine rule tells us that 12.1 over sine of 82 equals 7.3 over sine of x. This equation is a bit more difficult to solve. The first issue is that the x appears beneath the line in a fraction. A nice trick to get it out of here is to flip both sides of the equation. From here, there's two things we need to remove in order to isolate the x. The sine function in front of the x and the division by 7.3. We'll begin by getting rid of the division, and we can do this by multiplying both sides by 7.3. As the next step, we can simplify the left-hand side using our calculator. Now, to get rid of the sine function, we should take sine inverse of both sides. Turning to our calculator again, we can compute the left-hand side to see that x equals 36.7 degrees. To finish off this episode, get out some pen and paper and have a go at these two exercises. The answers can be found in the video description.